Welcome. Here we are discussing about implementation of linked list. Now we can go to a program. Here is the program. Here we create the node with the data that's stored in the value and next show the address of the next node. Head is used to show the address of next node. There are the function signatures. So in main we describe the options, ask the user to input an option. And using a switch case, we execute the given option and then using a do while loop, user is asked to they want to continue or not. If they enter 1, we will display the choices again, otherwise we will stop the program. So insert underscore back is used to insert a node at the beginning of the list. So here we declare the n, here we allocate memory for p, and here we check if the p and check if it is overflow, otherwise we ask the user to enter a value. And then we do p of data equivalent, p of next equal head, head equal p, which basically does is the value of null will be in p of next and head will have the address of p. And insert underscore end is used to insert the node at the end of the list. So here we declare p, temp and integer n, allocate memory of p, and using p we check if p equal null, if so we print overflow. Otherwise we ask the user to enter a value. And we check if head equal null, so we do p of data equal n, next equal null, head equal p, which is similar to insertion in the beginning. If head not equal to null, we assign temp with head and we using a while loop. We go to the last node and then we do temp of next of that node to be p of data equal n, p of next equal null, which basically put p as the last node. Insert underscore rand is used to insert a node at the given position. So here we declare p, temp, integer and pose. Here we give the memory allocation of p. Here and we check if p equal null. We print overflow. Otherwise we ask the user to input a value. And then we check if the position equals 0. If so we do insert underscore back. Otherwise if position less than 0 and position greater than get underscore count, we do invalid position. Here we check if position equal get underscore count. If so, we do insert at end. Here we check if head equal null. If so, we ask the user to enter a value. And if position n equal 1, we do what is similar to insert at the beginning, p of data equal n, p of next equal null, head equal p. Otherwise, if position is not equal to 1, we print cannot find a position. So if head not equal to null, we ask the user to enter a value. Temp is assigned with head. Using a for loop, we go to the position minus negative 1, we put p of data equal n, p of next equal temp of next, and temp of next equal p. So it put p in between temp and temp of next. So the display function is used to display the contents of the linked list. Here we declare temp and assign temp equal head, and if head equals null, we print overflow. If get underscore count equal 1, which get the number of nodes in the linked list, we display that one item, otherwise we use a while loop to display the item. So here get underscore count is used to number of nodes in the linked list. Here we declare temp and initialize c with 0. We assign temp with head with using a while loop. We increment c while going through the list till temp equal null and return C. And here delete underscore back is used to delete from the beginning of the list. Here we declare temp, we check if head equal null. If so, we print overflow, otherwise we assign temp equal head and head equal head of next. And we delete the temp, which makes the front node head. And then we delete, so delete underscore end. We delete the node at the last of the list. Here we declare temp and temp1. We check if head equal null, we print overflow. Otherwise, we assign temp with head and using a while loop, we assign temp1 with temp and temp equal temp of next. Finally, after the loop, we assign temp1 of next equal null and and delete temp, which makes the second last node and next value null and delete the last node. So next is delete underscore rand. Used to delete the node at a random position. Here we declare position. We check if head equal null. We print overflow. Otherwise we declare temp1 and temp3. We ask the user to input a position. Here, if the position is greater than set underscore count and less than 1, we print invalid position. Otherwise, if position equal 1 and if get underscore count equal 1, we do deletion at the beginning. Otherwise, we do deletion at the end. So, if it is not temp1 equal head and we do loop till it read the position and then we do temp1 equal temp1 of next and temp3 equal temp1 of next which goes to the two values in front which is like third node after the temp. If it is not temp1 equal head we do the loop till we read the position and then we do temp1 equal temp on of node and next temp3 equal temp1 of next which goes to the value the node after temp which goes to two values in front. Then we delete temp1 of next in the second node and temp1 of next equal temp3. So the second node is created and the first and third node are constructed. Finally, the search node. Final search node. So this is used if a number is available in the list. Here we declare temp, initialize number and 1 equals 0. If head equal null, we print overflow. Otherwise, we ask the user to input a number, assign temp with head, and using a while loop, temp not equal to null, we increment type. Using if statement, we check temp of date equal null. If so, we print the value and we return 0. Otherwise, we do the temp equal temp of next. So if the value is not found, it will exit the loop and we must the element you are searching for is available. So we run the program, we can see the output. So here is the output. We got the output. Thank you.